What's up everyone, and welcome to another Rust electrical tutorial. I'm Austin, and today I'm going to be covering the huge 2024 electrical update. I think this is going to be a major improvement for most players. So if you want to know more about how this video is laid out, just pause it here and give this a read. Otherwise, I'm going to go ahead and get started with a quick question. What about your previous builds? For the most part, this is not going to affect anything I've built, with the exception of at least one build that's now probably obsolete that I'll cover later. But if you're having trouble or you want help remapping the circuits I've built in the past, just get me on my Discord, which is always in the description of my videos, and I'll happily help you sort it out. So first off the bat, we're going to talk about logic gate power, which is the major point of this update. And really it is that these logic gates no longer require power. So if you run something to say an OR switch here, you're going to send 100 in and you're going to get 100 out. They don't require any power. And also they don't register active usage. And that's a huge point. They're not going to drain your battery. You can see that active usage is 0. And that's going to be the same for all these. That's a huge thing. If you think about what it takes to build some of these things, this is going to make stuff a lot easier. The next thing I'm going to cover is the electrical branch. Like I said over there, it doesn't require any power, nor does it register active usage. You will notice, however, that where it says no active usage is being used here, this chain of them still have their default 2 rust watts out from the branch out, and that is being registered. So it is consuming power. You have 92 coming out of here because we have 2, 4, 6, 8 being used in this chain. So you just know that just because they're not registering active usage doesn't mean that they're not drawing the power. If I were to take one of these branches out here and run this over to this switch I've got running to this turret here, you'll notice that the switch is on. It, of course, is also not registering active usage as we discussed. But if I were to run, let's see, 10 rust watts out of this, my turret is going to turn on. And so I'm going to register the 10 active usage of the turret. Really cool. If I say don't send quite enough, the turret is going to stop. It's going to shut down. And I'm still not using active usage. So I've got this set to 9, which means I'm using the power. I've got 85 coming out of the end here. But I'm not using the active usage unless the item that it's powering is physically running. And so that is great. The switch itself, again, no power, no active usage, so much easier to set these up. If you need 10 rust watts for a turret, you can hook up all this stuff, and you're running all this stuff for an active usage, so charging requirement of just 10. So that's that. Next thing I'm going to cover is the shift snap spacing, I've been calling it. And this is a really cool thing they added where if you place something on a wall, and note that they don't rotate anymore. The switches now remain perfectly vertical instead of sort of rotating over as you go away. If you were to press shift here, it's going to snap this in line with this. And whatever that gap is between there, it will then keep that gap going for you as you go. So if I were to put one above it, I can also shift snap to where it's now above that one there. And what it'll do is if I shift snap it, if I hold shift, it's going to now align it here, but not with the one below. If I go to the one below, I can shift it there, and now it's here. So for this next one, if you're just very careful how you place it, you can then now have this perfect line of whatever. And this works with anything that you have going on. It'll work for whatever you're doing. So there's some limitations. I've noticed there's like a distance limitation, but all in all, just holding shift to snap things is a really, really cool thing. And that distance is going to be dictated by how close that next one is. So now they're all going to shift snap to that interval there. So pretty cool stuff. Next thing I'm going to cover is the difference in splitters. This is an absolutely awesome update that they've done. You'll notice that I've got this set up. I've got 3 coming out of here so that I have these splitters. If I were to switch this to 2, you'll notice that now only the first 2. So there's 2 things happening here. One, obviously these don't require any power anymore. So this is all active usage 0. None of this is registering on the battery at all because all of these are part of that update. But what's important here is that now the splitters are doing a better job of breaking up the power that you're running through them, and they now will not waste power. So if I set this to 3, it's going to break it up into 3 for these 3 items. If I set this to 4, you'll notice that now the first one has 2 coming out of it, and the last 2 have 1 coming out, because splitters have a output priority of power out 1, 2, and then 3. So what it'll do is if I add 1 more, it's going to now it's going to split it up into this one here. So now we're on 1 and 2 have the most, and then if I make it the full 6, now we'll be at these two coming out. So that is a really cool thing that they've done, and quite frankly, that opens up a ton of possibilities for you to play with. The next thing we're going to cover is logic gate active usage, and this is also really cool. So in addition to the things I talked about in the first section over there, it's also going to change how these things operate. So if I were to select the large battery, put that to input A, and then select this small battery, hit that to input B, it's going to do the same thing that it always did, in that it's going to prioritize the largest power amount, the biggest power you have going in. It's going to pass that power specifically. It's going to power this light in this case, so we have 99 left over and an active usage of 1. That's the light specifically, not the switch, not the counter. And so, but also if you were to, let's say I were to unhook this and I were to hook this battery to A and then hook this battery to the other side here, it's going to power it. Right, here we go, we're using 1. Notice that the active usage is 1 on this battery specifically and not this battery. So it's going to prioritize the active battery where they are the same, if you have the same coming in, to the A input over the B input. And this is much better than the other way. This allows you to make much more complex and, quite frankly, intelligent logic gate designs. And that's the same across with any of these logic gates. The OR switch here, the OR switch will pass either, and whatever one is greater, it'll pass that one. So if I were to hook up this large battery to this OR switch, it's going to pass, turn that light on. Here's that active usage of 1 from that light. If I hook up this one over here, it's going to register it, but it's not going to do anything. This still has an active usage of 0 because this input A on this battery is greater, and that's great. If you do the same thing we did over there, where I hook, say, this battery to A and then B to, say, this battery, you'll notice that they're both active, but only the A side has the active usage because it is in the A port. So it's going to prioritize, just like the splitter thing I just talked about. It's A, then B, if you have the same settings. And for things like the XOR switch, this is another great example. If I were to run this to the XOR switch, obviously it's going to work because the XOR switch only passes power if it receives 1 and passes there. So really the larger power doesn't really matter here, but here we have 99, active usage 1. If I were to hook this up to it, you'll also notice now it doesn't pass power, and importantly, neither battery have active usage. So this won't drain your battery if it is not able to pass power, and that's really cool. Again, much more intelligent logic circuit possibilities here across the board. Next thing we're going to talk about is the memory cell active usage. I'm incredibly excited about this one. This is the one that negates one of my builds. The power sharing video is pretty much useless at this point, and I'll show you why. Is that one, this now actually tells you which output. So if you're on the inverted output, which is the default output, it's going to register how much rust watt you have going through there. And the other one's going to say 0. It never used to do that. It used to split the difference, or sometimes nothing. You never knew. So they fixed that. Excellent. Thank you. And importantly now, so here we have it set to the large battery, which is running this tiny little light here. If I were to swap this over to this turret, now it's going to show this coming out of the turret side. And note that the active usage on this side is 10, not 1, and it's not registering anything over there. It used to have this issue where it would drain active usage. Battery drain would occur on both banks here, even though only one was supposed to be active. So they fixed that, which is why this negates my power sharing video, because I had blocker setups and this stuff to deal with this to fix that problem. But now the memory cell does what it's supposed to and will power share correctly. So for power sharing, now you can just set one of these up, have half your defense on one side, or your defense on one side, your crafting on the other side, simply switch between the two, and the battery will power only one side of it and not register anything on the other side. So that is awesome. The next thing I'm going to cover is the industrial conveyor power. They still require 1 rust watt to operate. However, now you must supply the second rust watt if you want to use the filter pass or the filter fail. So in this particular case, I've just daisy chained these together, and this is set to its default of 2. And so you'll notice that it is powering the first and second conveyors, but only allowing the filter fail on the first one to operate. So what I figured out was, if you want to use a conveyor, set of conveyors, whatever, and both of their outputs, it's going to be the number of conveyors you have plus 1. So in this case, it's going to be 3, and that will power the 2 conveyors that you want plus their outputs, and then technically a third one. So Here I have 5 conveyors, 1, 2, 3, 4, 5. If I were to set this to 6, so 5 conveyors plus 1, that'll turn on all 5 conveyors and provide the extra power I need to get through all the way to the end for my filter fail. So if I were to test this by setting this to 5, you'll notice that the last one does not have the ability to use its filter pass or filter fail. So it is going to be conveyors plus 1 is your setting if you want to use all your filters. Another quick note about the industrial system, the industrial crafter now does require, it does use an active usage in your battery. So you're going to have to be aware of that, especially with my factory videos, things you're building, whatever. You do have to account for active usage on the industrial crafter. Also notice this is an active usage of 10, and that's because this is free. We don't care about this anymore. But now you have 5 conveyors and 5 lights. So it's a little more specific in some situations. So be aware of that when you're powering things off of this, depending on what they are. You might have an active usage and therefore charging requirement. Okay, so the last thing we're going to do is take a look at an example that I made here that makes use of a lot of the major points of this electrical update. You'll notice that I've got a bunch of OR switches over here. I've got a light up there. I've got 8 HBHF sensors, 3 splitters, some branches, a switch, a counter, a power distribution branch down there. And if I turn this on, here we go. You'll notice that I have 8 of these going. Each of these HBHF sensors is running to one of these inputs on the bottom OR switches, which are then trunked together into a single output up there. And you'll notice that even with all this stuff hooked up, I only have 9 active usage, which is pretty crazy. I've actually avoided doing things like this in my videos. One of my HBHF sensor videos, I have specifically avoided this because of the power requirements. And what you'll notice is that I am sending just 2 rust watts to each of these HBHF sensors. And their output, they're using one because they do require power, and then their output is running to one of these inputs, and that single rust watt is traveling all the way through this for free to this output, turning on this light. So this is a way for an active usage of 9, which is simply the 8 HBHF sensors. That's 1 for each one of those. And then this light specifically, that's the 9. Everything else is completely power free. I'm just sending from here, 16 rust watts out of here. This is for 16 rust watts. I am running all of this. This could be like a network of sensors around your compound that pick up players as they come on, as they enter your area, for just 16 rust watts and a charging requirement of only 9 active usage, which is really, really incredible. So this is just kind of a way to visualize some of the things that this update is going to allow players to do. So the last thing, I'm just going to kind of look over here, some additional just points on the update. There's a lot of stuff in this update that I didn't really cover, that are just small things. But some of the more specific things I think are good to know is that the timer values can now be set when they're not powered. So you can set a timer to whatever you want prior to powering it. I mentioned the industrial crafter now drains power when it's on. Ceiling lights, I kind of actually had this down here. I didn't really touch upon it, but the ceiling lights now do require 2 rust watts. So if I were to run this over to this switch here for these ceiling lights. There we go. Turn those on. There we go. We have our ceiling lights. Notice that this is only 12 active usage for all this. So this is really using the 2 rust watts, which was not the case. You used to be able to power them with 1. That has been repaired. The industrial conveyor can no longer be deployed on itself, so you used to be able to kind of stack these things out weirdly, but they fixed that as well. So there are some more things that are little tidbits about the update, but this is pretty much the gist of it. And so that, folks, pretty much does it. If you have any questions or comments, you can leave them below. Otherwise, you can get me on my Discord. See you later.